last subunit of astronomy is about the moon. Background, no big deal there. We think the moon formed when something about the size of Mars collided with early Earth. We think it's essentially some blown off Earth crust mixed with this other object. We named it Theia. Call that the big splat. Notice we have a big and everything. All right, some physical properties of the moon. All right, the moon's about 2,000 miles in diameter. If you look at the Earth, Earth is about 8,000 miles in diameter, so the moon is about a quarter the size of the Earth. You can fit 4 of them across the face of the Earth. Right? Gravity is about 1/6 that of the Earth. Right? And the reason is because there's a lot less mass. Right? Mass equals gravity. So if you weighed, let's say, 120 pounds on Earth and you went to the moon, you would weigh 20 pounds on Earth. You just take your weight on the Earth and divide by 6. The moon does not have an atmosphere, all right, because of such a weak gravity. Any gases that might have come out of the moon while it was cooling kind of flew off into space, left it without an atmosphere. And because of no atmosphere, on the lighted side of the moon, the side that's facing the sun, it's around 250 degrees Fahrenheit. I mean, we get upset with a 100-degree day here on Earth, you know. So, and then it's around negative 250-ish on the dark side. So the reason for that is because there's no atmosphere to move energy, to move that heat around the moon. So it's hot when the sun is beating on it, and it's cold when it's not. All right, the moon's revolution. Counterclockwise, just like us. There's a couple different numbers you need to know. The period of revolution from the reference table, 27.3 days. That's called a sidereal month. You don't need to know the name of it. But the more important number is the 29.5 days. That's how long it takes for an entire cycle of phases to go through. So new moon to new moon, full moon to full moon, whatever. But it takes around 29.5 to 30 days, and that's where we get our month. That's where we get our months long, is the synodic month. That is not in the reference table, okay? And that's probably the more important number, but it's not in the reference table. All right, looking at the orbit, just like our orbit around the sun is an ellipse, and we have aphelion and perihelion, the moon's orbit around Earth is also an ellipse, and it has perigee and apogee, so near to the Earth and far from the Earth. All right. Same principle. The moon revolves around Earth in an elliptical orbit with Earth at one focus. And this causes the size or the apparent diameter of the moon to change cyclically. When it is closest to us, perigee, it looks big in the sky. And when it's farther away, it's going to look smaller in the sky. It doesn't change size, it's just perspective because of how far away it is from us. All right, phases. The reason we have moon phases is because the moon revolves around the Earth. At any one moment, a spherical object in space is lit up by the sun on one whole half, one entire half. Well, we see different percentages of that illuminated side, and that's the phases. If we see none of that illuminated side of the moon, it's called a new moon. If we see all of that illuminated side, it's called a full moon, and then you have in between crescents and gibbouses. All right, so new moon, again, doesn't appear to be illuminated. In other words, we're not seeing any portion. The other side is what's illuminated from us, from our view. We call the new moon the starting point or the beginning of a set of phases around Earth. I mean, it doesn't really matter where you start from, but we just have to have some place to go because it's cyclic. All right? Full moon, okay? Fully illuminated half we get to see. Remember this whole set, we figure if we say 30 days, so from new moon to new moon would be 30, so new moon to full moon would be about 15 days, a little over 2 weeks, because there's a little, 4 weeks in a month. Okay. Crescent moon, is less than half of the illuminated portion can we see. Okay? Less than half of the illuminated portion that we see. Looks like a little fingernail. And the gibbous is more than half of the illuminated portion that we see. Okay? We don't see the full moon, but we don't see a quarter moon either. Okay? The crescent is less than a quarter moon, and the gibbous is more than a quarter moon. And by the way, here's our quarter moons. Okay, first quarter, the right side is lit up. We call that the waxing quarter because when the moon is becoming more full, we say it's waxing. And when the left side is lit up, we say the moon is waning because the lit portion is going away. It's becoming closer to new. Right? All right, so waxing is the moon's visible portion is increasing, going from new to full. Waning is decreasing of the visible portion, going from full to new. All right, so if we look at this diagram, whenever you have a diagram showing the Earth and the moon at various phases or positions around the moon, around the Earth, you want to find where the sun is. In this particular instance, the sun is on the right. They're not always going to show it to you on the right, but in this instance, it is on the right. So therefore, the new moon phase is going to be when the moon is between the Earth and the sun. And this is what we see. Okay? If we're on the Earth here looking at the moon, we see the dark portion. We see the entire dark side. Okay? And then as we go counterclockwise, we see a little more. That's called a waxing crescent. We see more. That's called the first quarter. We see more. That's called the waxing gibbous. Until eventually we see the entire lit up half. That's as much as we can possibly see. That's our full moon. Then we start seeing less. So now we're seeing a little less than a full moon. That's our waning gibbous. Seeing even less, that would be our last or our third quarter. See even less, that would be our waning crescent, until eventually we're back to it again where we don't see any of it, and that's our new moon again. And again, all 8 of those phases, all the way from 1 to 1 again, takes a month, takes 30-ish days. All right? So here's going to be about 7, 8 days. Here's about 15. Here's about 22 days or so, and then back to a month. All right? All right, so again, we start with our new moon. We see a little more, we're waxing, that's crescent. We see a little more, we're still waxing, that's first quarter or waxing quarter. We see a little more, that's a waxing gibbous, until eventually we see the entire half that's lit up. That's a full moon. And then we see a little less. So it's waning now. We see a gibbous because we're seeing less than the full moon, but we're not seeing a quarter yet. Now we're seeing a quarter, third quarter, last quarter, waning quarter, however you want to word it. And then we have the waning crescent when we're all done. All right. All right, eclipses. An eclipse is when light is blocked. All right. So a lunar eclipse is when the moon falls into Earth's shadow. Just like you cast a shadow on the ground when the sun is out, the Earth casts a shadow out into space. And as the moon is going around the Earth, if it moves into our shadow, so it's on the opposite side of the Earth from the sun, that's a lunar. Okay? That's a lunar. All right, so when we see that, it's going to look something like this. Notice it takes on that bloody brown red color halfway through. Right about there. And that's because of the color red wavelengths get kind of refracted around and reach our eyes. All right, get rid of that. Okay, we only get a lunar eclipse during a full moon. Okay, so it has to be the night side over here. So it has to be a full moon. Solar is when the moon falls between the Earth and the sun. Okay? And this is visible during a new moon. All right? So lunar is when the moon goes into Earth's shadow. Solar is when the sun is blocked by the moon. This one here happens to be called a total solar eclipse. If the moon is at perigee, meaning it's close to the Earth, it can look big enough in the sky that it could conceivably block out the entire sun, and that's called a solar eclipse. All right? And this top picture here, notice how the moon and the Earth and the sun don't exactly line up. The moon is still between the sun and the Earth, but it's not exactly in line. So just part of the sun gets blocked. That's called a partial solar eclipse. It's going to look something like that. You're going to get part of the sun being blocked. Okay? On the bottom, now we have what's called an annular solar eclipse. Here, the moon is at apogee. The moon is far away from the Earth, and because it's so far away, it looks really small in the sky, so it can't completely cover the face of the sun. And so we can actually see the edge of the sun around the moon. It's like a little ring of the sun around the moon. All right, and this is the three types. On the left, we've got the total. On the right, we got the partial, excuse me, middle, we got the partial, and on the right, we've got the annular. You can see how they compare. Notice the total and annular look very similar until you start to get about halfway through. And look, you can see right there, in an annular, you can't see the atmosphere of the sun. It's called the corona. But over here, you can see that atmosphere, that fringe of the sun, that atmospheric fringe, that corona. Kind of an appropriate thing, right? Right? But because the moon is so big, it covers up the entire sun and allows that fringe to show up. But when the moon is smaller, it can't quite cover the entire sun. And you're not going to see that fringe. It's going to blend in with the edge of the sun. All right? All right. This is kind of how we get eclipses. All right? In the top picture, notice that the moon's orbit doesn't line up very well with the Earth's orbit. All right? There's actually about a 5-degree tilt from the Earth's orbit to the moon's orbit. And because of that, even though we still get a new moon when it's here and a full moon when it's here, the light can still pass by, and so you don't get an eclipse. This is how the moon is normally situated on the Earth. Well, because there's a slight wobble to the orbit, the bottom picture sometimes occurs. Sometimes the moon wobbles enough where it's actually pretty close to being in line with the sun and the Earth. And if that happens when it's between, when we get the new moon, that's when we get a solar eclipse. Or if it's on the other side, during a full moon, that's how we get a lunar eclipse. Okay? But it's because of that tilt of the axis. The axis of the moon doesn't line up precisely with the Earth's orbit. So that means we don't always get an eclipse when we have a new or a full moon. All right, near and far side, okay, because of the rotation and revolutionary rate of the moon, I'm going to show you that here right now. If we go to our reference tables, and we go to the bottom chart, notice that our rate of revolution and our rate of rotation for the moon is the same. It takes 27.3 days for both. Because of that, that keeps the same side of the moon facing Earth. It's rotating and revolving at the same rate. Okay? The only reason that the only way we know what the other side of the moon looks like is because of photographs that have been taken from space. Nobody that's ever stayed on Earth, which is most of us, has ever seen the other side of the moon live. We only see photos or video of it. And that's because of these two things. All right? All right, tides. The tides are the periodic rising and falling of the ocean. When we talk about sea level, What we're really talking about is the average height of the ocean. Because we have high tide, we have low tide, so we take the average. Right? Tides are caused by the moon's gravitational pull, but they're affected by the rotation of the Earth and the pull of the sun. First thing to keep in mind is that the high tides always line up with the moon, no matter what. They always line up with the moon, and the low tides are always kind of perpendicular to those two. So even though we're going to throw the sun into the mix here, just remember to keep the high tides in line with the moon, no matter where it is. If you put the moon up here, high tides are going to be in line like this. Okay? Period from high tide to high tide. So from the Earth to rotate from here to here, even though the Earth rotates in 24 hours, it takes more than 12 hours to get from here to here. Right? Because as the Earth rotates, the moon is also revolving around the Earth, and so it has to rotate even further to get back in line again. So it takes more than 12 hours to go halfway, which means it takes more than 24 hours for one complete revolution to go from high tide to high tide to high tide again. All right, we're talking about 25 hours to go from here all the way around and back to here again, because the moon has now moved up here, so it's got to go further. All right, I've got a little graph of tides. If we look, our first high tide on this graph is around 1 a.m. Our next high tide is around 1:30, because I said it was about 12 and a half hours, so it's about 1:30 p.m. So if we go 1:30 p.m. and we add 12 and a half hours, that would be about 2 a.m. Somewhere over here would be the next high tide, right in this area somewhere. Okay, because it's going to continue on like this. All right. Our low tide is right around 7:30 in the morning. See that? 7 would be about halfway, so it's about 7:30. Our next low tide is 8 a.m., or excuse me, 8 p.m. So if we take 8 p.m. and add 12 and a half hours, we're going to get about 8:30 in the morning. So if we have the high tide here, jump back down here like this, our next low tide is going to be about 8:30 the next morning for our next low tide. Okay, so each one, high tide to high tide is 12 and a half, low tide to low tide is 12 and a half. So that means that high tide to low tide, if we go from 1 to 7:30, is about, a little over 6.5 hours, a little less than 6.5 hours, excuse me, like 6 hours, 15, 20 minutes to go from high to low. And then another 6, 15, 20 to go from low to high, and then another 6, 15, or 20 to go from high to low, and et cetera, et cetera. All right, we have a couple different special tides to finish up with. All right, first type is if you have either full moon or new moon, which means the moon, the sun, and the earth are all in line. Either sun, moon, earth, new moon, or sun, earth, moon, that would be full moon. If they're lined up, the sun and the moon are going to work together. They help each other. And that gives us more extreme tides. We get higher high tides, lower low tides. Those are called spring tides. Okay. If the moon is at the quarter phases, you notice that the sun is lined up with the earth here. If it's at the quarter phase, so either first quarter or third quarter, now the sun is working against the moon. The sun, the earth, and the moon are perpendicular to each other. But remember, notice the high tide still lines up with the moon. Even though the sun is so much bigger, it's so far away that it doesn't have as much impact as the moon being so close. All right? So they're going to work against each other, and now we're going to get less extreme tides. In other words, our high tides aren't going to be quite as high, and our low tides aren't going to be quite as low. We call these tides neap tides.